Do we understand all the bonds?
Not really, no.
Okay, so we'll go over the bonds. We'll break it down super simple. Here's your bond chart. If you can understand that chart, you know all 4 of your bonds. So there's covalent, and covalent's been broken up to 2. I'll write this down actually. So we have our covalent bonds, and that branches out to polar covalent and nonpolar covalent. And then we have ionic bonds and then hydrogen bonds. So we'll start with ionic bonds. So ionic bonds is going to be when we have a complete transfer. If you see that word in the definition, you automatically are going to know it's an ionic. So complete transfer of electrons. Okay, so this is kind of our dating or our marriage scenario. So you can kind of look at them all of like, oh, and there's an attraction one, covalent bonds are more dating scenario like. Ionic are going to be our marriage ones. So complete transfer. So if we look at sodium and chloride, one's a cation, one's an anion, or one's a positive ion, one's a negative ion. Sodium is going to have 11 electrons, and chloride's going to have 17 electrons. And this is all information they would give you on the test too.
Okay,
They want to right? They want to say how much does sodium have. They'd give you the scenario and then maybe ask a question about it.
I was starting to get a little bit worried.
Luckily, you're like, wait a second, we have to memorize all this. No, you can hate your life when you go to a chemistry class. Not right now, but I'll let you know. So we have 3 shells that we worry about for this class. And then we call them valence electrons when we're trying to fill the shells. So let's say we have magnesium. I don't even know how many electrons magnesium has, but how many does it take to get a full inner shell? You guys remember?
2.
Yep.
Okay.
2. And then what about our next 2?
8.
Yep.
8.
So this would make an ion or an element kind of happy or stable, is if they can have full shells. Okay? What if this just looked like this? Is this a stable one?
No.
Mm-hmm.
It is. And the only reason it is because its most outer shell is full. If this had only one in it though, we would call it unstable.
Okay.
Okay? So as long as the farther out shell that you're going is full, 8 out of 8, it's happy.
Okay.
If it's maybe like 7 out of 8, it would be unstable.
Okay.
Okay? So let's fill in the valence electrons for both of these, and then you'll be able to see why they would want to come together. So how many on the inner shell, if we have 11 total?
Well, there's 2.
2. How many on this one?
8.
1, 2, 3, 4, 6, 7, 8. And how many out here?
There's 1.
1. Is sodium stable?
No.
No. So it's going to want to bond to something else to fill its shell. Okay? Let's do chloride. How many on the inner? 2. How many on the middle?
8.
3, 4, 5, 6, 7, 8. And how many outside?
7.
1, 2, 3, 4, 5, 6, 7. Okay, so is chloride stable by itself?
No.
No.
No. Why not?
There's only 7 on the outside.
So sodium chloride, they can come together and bond, making NaCl. Notice not one of them's positive and one's negative anymore. They kind of cancel each other out. They're bonded because this one says, oh, I'll give you 1, you give me 7. Come together, if we could like squish our pictures together, and they can bind together. So that's table salt.
Okay, so it's not really a case of Because I know when I just first look at it, I just want to say, okay, well, the one electron from sodium is just going to leave to chlorine, but then they're not combining at all, are they?
Right.
And is that a form of bond where just one electron leaves, or is that just me
Nope.
pushing it to that? Okay.
I think that can happen, but it won't be considered a bond.
Okay.
So when you say transfer, they're really just like combining.
So that's
one.
where it's nice to kind of look at the marriage scenario. If you see this is one is marriage. So when you're married, you give 100% of yourself to another person, right? But you're still you. You're still Abby. Even if you get married and give 100% of yourself to someone else, that's kind of the scenario that's going on here.
Okay.
So while this is kind of giving away its one electron, it's kind of keeping it too, because they're just coming together. Does that make sense?
So if would they ever ask a question like how many electrons are in the outer shell of NaCl? You just say 8, right? Because it is 8 now.
Right.
Okay.
Yep. So the questions that they could ask you about an ionic bond, I would go back to this test and see which ones they asked, but I would figure that they would give you ionic bond, covalent bond, nonpolar covalent bond, polar covalent bond, hydrogen bond, then all the definitions and have you kind of match 1
which
to
is
D.
which, okay.
So that would be a really easy scenario for just the definitions of bonds. But then they could ask you, given the fact that sodium has 11 electrons, how many is in its outer shell? Is this ion stable or non-stable? Things like that. And you'd say, oh, there's 1 electron in the outer shell. The first 2 shells are full, and it's unstable. So P, or whatever it is. So ionic bond's the hardest one of all.
Ionic bonds are unstable? Is that, sorry, what you just said?
Or sodium would be unstable,
sodium.
all of them.
Okay, got it.
Right. But ionic one is the most difficult to understand.
Okay.
Okay? But remember, we had a cation and an anion. So positive one and negative one come together.
And that's a key to the definition, right? The ionic bond will always be one positive and one
Right.
negative.
So there's your ionic, and also your mini lesson on valence electrons, which is just how many are in the outer shells. So ionic, we can just give the example of NaCl.